Hi, welcome back. This is day 20 of Advent of Code. I'm Liz the Gray, and it's been a wonderful and fun 20 days. We've just got 5-6 more days to go. So we have a puzzle unlock that's happening in about a minute and a half. Specifically, 1 minute and 50 seconds. And I just finished my day 19 a couple of hours ago. I'm feeling so much better than I was last night. Yeah, don't try to do puzzles while you have a raging headache. It ends really poorly. The thing that took me 20 minutes last night easily could have taken less than 10 minutes, and I was able to pretty quickly polish it off. So I'm feeling pretty happy about that. Awesome. Let's just go ahead and dive into this. I wonder why Twitch thinks that my bitrate is low. It shouldn't be. That actually looks like a fine bitrate. I have no idea why it's complaining. Oh, average stream bitrate is too high. Well, that's not exactly my problem, Twitch. You're supposed to just deal with that. All right. Cool. Let us see what we have over here. I hope people's weekend has been going good. I think that hopefully the puzzles will get a little bit more interesting because people may have time off. People may be in a situation where they are able to devote a little more time to the puzzles. So Eric can set the difficulty a little higher than before. So we'll see what happens. We'll see. All right. So let's go ahead and create my sample files, create my code files, and then we'll go ahead and get started with the puzzle the instant that it unlocks. Cool. All right, so this is day 20 now. I'm glad that you're having fun, Make Effie. Okay, so we're on the high-speed train. We're looking at the satellite imagery, by the way, which is of this monster here, this Loch Ness monster that's in the oceans. So there are many image titles that have a unique ID. Each image has been rotated and flipped. The border should line up with its adjacent tiles. Okay. Yep, so those things have to exactly match. All right. Cool. Multiply together the 4 corner tiles. Okay. I am really excited to do this. This seems really, really fun. All right. So let's paste my input here and make sure indeed that it ends in 3191, which it does. So we need some kind of way to encode each tile. And I'm noticing that these are 10. So we essentially can use a bit mask to record what the edge of each tile is, which will help us. Okay, cool. So let's go ahead and take a quick gander at this. So the format of this is tile something something. So each tile has some internal detail which we don't really need to care that much about. And specifically, it's going to have, each tile is guaranteed to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so they're all 10 by 10. This is kind of memory inefficient, but I think it'll probably be fine. And I'm just going to define, how shall we do this? All right. Cool. All right, so how shall we think about this? So let's do this way. All right. First line of metadata describes the tile ID. So this should be so 0, 1, 2, 3, 4, 5. Okay. All right. So we've got a header. And we don't want to have the colon in there, so that seems fine so far. All right, now, all right, so the line is going to be split of I. So in fact, I plus equals 10, 11, 12, I think, per time. Because there's going to be one line of header and then the new line after it. Okay. All right, so if line of, does it specify which bit is which? Okay. Then tile of R of C is true, otherwise it's false. Okay, and then now we have tiles all right. Let's just make sure that I correctly parse everything first. Actually, wait. All right. Cool. So let's give that a run, see how that does. Okay. Oh. Fill that in the boilerplate for now. Why does tile not support indexing? Oh. Because that should literally just be that. Okay. Alright, so there are 144. There are 144 here. Okay, that makes sense. That feels pretty good. Alright. So, this is definitely going to be one of the more interesting algorithmic puzzles for sure. So now let's develop something that will actually produce a checksum of the edge. And let's also record the simple example first, just to make sure that our code works on a smaller example. All right, and there are indeed 9 tiles in that. That's good. Okay. So now, so I want to think about, can 2 tiles be put adjacent to each other? They can put adjacent only if top and bottom are the same. Or, okay, yeah, they can only be put together if top and bottom are the same, or if left and right are the same. So those always want to be left to right, just for ease, and top to bottom. So reading along the top, let's see, how do we do this? So left to right, so if V, then top. Okay, I think that works. So we'll do the same thing for T of 9. Okay. If R of 0, then left. If R of 9, then right. Okay. So let's just make sure that all of these are working correctly. It is. That would seem to have a bug. That does not seem right. So I am, for some reason, not saving to bottom. Oh, yep, that would do it. Okay. Why is that not working? That should definitely be working. So why is... So this is failing to... Oh, I see. Why is the top of the tile never having any bits set? That seems not correct. Let's just print one of the tiles really quick. I am deeply skeptical of this. Something funky is going on. Yeah, okay, that is indeed never being set, so that is a problem. Oh, I see. My problem is this. Okay, now that looks more or less correct. So now we should be able to see that some of these should have the same checksum. For instance, 680 goes with 680, 532 doesn't go with anything because there is the potential for them to be flipped. Let's just make sure that that still compiles. Okay. So I need something that is able to flip an edge as well. So the flip needs to essentially reverse all the bits in it. E. And 1. Okay, I think that does it. Seems right. Oh, no. E shift by I, &1. Okay. Let's see. All right, so that makes sense. So now each tile should have a companion somewhere that we should be able to stitch together. So, simplest way to find this, I think, is there are going to be tiles that don't have any matches whatsoever on two of their faces. I think that's probably going to be the easiest way to identify which ones are funky. So 948, 948. Oh, but that 183 went to 183 anyway, so that's fine. All right. So let's solve this the lazy way. Here is something that has a debug. There we go. All right. Okay, now let's see. All right, so now we've got tile IDs. Okay. All right, all edges E. See whether the silly way solves my problem the easiest. And we append E. And, append I. So each edge type, let's see. Okay. Where is this not used? Oh, the I is not used. Why is the I not used? Oh. Because this is not needed here. Okay. Okay. Okay, so here have a number of candidates that only appear once. Oh, but we have to figure out, some of them can be only appearing once because they only match on the bottom. or on one edge. So we need to find out. Okay. That should do it. So now, yep, those are my 4 corner tiles, and those indeed are, wait, 1489, 2729, 20, oh, I've now identified my side tiles, so that's not it. So, I think that does it. Because I want things that have exactly 2 weird edges. Okay, now that's correct. All right. So that was a little cheesy, but we did it. Right. So that yields that number, which is correct. So we'll paste that in here. And that's correct. Rank 396. Not bad, not bad. So now check the image for sea monsters. Remove the gaps to form the actual image. And we want to look for a sea monster pattern that matches a... So you want the roughness that, so find the things that are not sea monster, mask them out, and then, so there could be more than one sea monster as well. Okay, I understand this. All right. So we have our 4 corners. So we're going to need to take our 4 corners and take our bottoms, and we're going to need to assemble that together, and then based off of that, we can iterate and fill in the pieces gradually. Okay. I think I see. Okay. It feels like Eric could have given us a pathological input that that doesn't satisfy this condition, where there's more than one potential match on an edge. But the good news is, tiles of the outermost edges won't line up with any other tiles. Okay, so we were given that explicit hint, which helps us. Okay, cool. All right, FV. Okay. All right, so. All right, so just print this for now. All right. Run that real fast. So wait, that's not right. Oh, because I did that. All right, so we found 4 corners, 40 sides. Does this line up? So I've got 144, so it should be, yep, 10, 10, 4, 4. Yep, okay, that's correct. Yay, thank you for the cheer fixer. Awesome. Cool. So now we can fill in wait, but how do I know which side is right side up? You might need to rotate or flip your image before it's correctly oriented to find the sea monsters. Okay, so at the end of this, we're going to have to apply a global rotation. All right, that's fine. So, image. Okay, so okay. So we're going to need something that's going to be able to crop this. That should do it. Great. And then we're also going to need some mechanism of storing the mosaic. How do we approach this here? All right, so a rotated piece is going to consist of a tile ID, and it's going to consist of a rotation. I swear I can spell. Rotation, let's also, all right. So it's possible for things to be rotated or flipped. All right. So we are going to start by taking one example. Okay, mosaic. do this. Oh, so mosaic is not actually a... All right. So we're going to define the mosaic really fast. Okay. So side length is going to be length of tiles so that's going to be 144, but I need its square root. How do I quickly square root it? Oh, actually I don't need to do this. All right. Are any mosaic... Okay. No mosaic tile piece is numbered 0. So I can know for a fact that if a tile is not marked, then it is... if a tile's ID... If a rotated tile in the mosaic has ID 0, then we know it's not a real one. Okay. Okay. I want everything to eventually be addressable, so... Also, I want this to be... I want us to be able to modify these in place. Is that correct? No, let's leave it the way it was. That's fine. Okay, so that should work. So now, I'm going to arbitrarily set this one to one of the corners. So we need to, just going to quickly set this here. Does Golang have multi-line strings? It has a back quote. Okay, yep. No, not that button. Wrong button. Help? That's weird. I'm strangely stuck now. Okay. I have no idea how or why that happened. I didn't mess up that terminal too. Good, okay. Okay, I think that does that. And 157, oh yeah, I didn't finish filling that in. Let's not do this as a map. Let's do this as a yeah. All right. Okay. So that one dot tile ID equals. All right. So now we have our starting place. So now we need to fill in the top, and then we'll find the corner that matches, and then we'll fill in the next row and so forth. Okay. Okay. So all edges needs to not just say what all the edges are, it needs to also say how I rotated and in or flipped that piece to get that result. Yeah. Okay. Before I proceed any further, I'm going to check my code in. Because I might be doing some disruptive changes here. All right, we'll push that up to GitHub. All right. How do we do this? Guess I need to record the rotation required to get it here. You know what? We'll figure it out. Okay. And I want the right edge, which is going to be index 4. we've got a bunch of edges. Hey, Eric. I'm working on part B. This is definitely going to shape up to be one of the more fun ones. I'm pretty excited by it. I know it's going to take me a while, but I'm pretty excited by it. Okay, top, bottom. Oh, but these have to exactly match in order. So top, right, bottom, left. Oh wow, someone's already done with part 2? That's awesome. I'm glad for them. It is going to take me a little bit longer. Oh. We need to... so how do we do this? I guess we need to look through all of the I see how to do this. What we do is we start from the top left, we iterate around in a circle until we find a solution. After that, we can reuse that function and work one smaller, I think. That's probably the correct way to pattern match all of this. Okay. So we need to fill in all of these pieces until we have the grid completely filled. And then after that, we look for sea monsters. And then after that, we... Okay. So my candidates are just all the edges. Or sorry, my candidates are the sides. All right, and I will need to know which direction it is. If E let me think about this, because now the direction is going to start mattering. All right, so if it's loose edge, then we know how it's rotated. If it's the left unmodified edge, don't rotate. Otherwise, some work to do. Okay. then I can break outer if I find a match. Oh no, it's continue outer. All right. Yeah, today's puzzle is definitely pretty involved. I am going to peek really quickly at the leaderboard. Who is done? Yeah, 25 people are done. Yay, Sophie Alpert. Sophie Alpert is awesome. I think she's amazing. Okay. If E correct orientation. All right. So I'm glad you put this on a Saturday, Eric. I am so glad you put this on a Saturday. All right. All right. All right. So I am going to want to encapsulate this as a function at some point. I just want to make sure that I finish it first before I encapsulate it as a function. Okay, so right now, as written, how do I do this? Image 0c dot tile ID is going to be oh, wait. Okay, that has to be that. Okay. So I'm reading top to bottom and right to left, or sorry, left to right. Just think about this. So if I find the left edge, then the loose edge is going to be This is recomputing a bunch, but that's fine. And it's going to be the right edge. And the rotation is going to be none. And the flipped. Okay. What if it matches the right edge? If it matches the right edge, this is almost calling for me to get some paper out. What to do? All right, we're doing this. We're doing this. I'm not sure how well this is going to look to all of you because it is mirrored, but you're just going to have to deal. All right, I've got 2 pieces of paper here. Got 2 pieces of paper. So let's think about this for a second. All right, so we have top, right, bottom, and we have left. I'm going to write this on both pieces of paper. Hopefully this should be somewhat clear. So if a right and a left go together, then I know that I haven't modified this one, and I know that the rotation is unchanged. Now the trick is, what if it matches on some other axis? There are a lot of different ways to consider. So I also need to write on the opposite side about what about the flipped case for at least one of these. So in the flipped case, so in the flipped case, this is still the right okay. This one here is top now, but it's reversed. This one here is left. And this one here is okay. So let's see. All right. So if I'm working off the right edge here. So if I see a left edge, I'm good. What if the thing that matches is a bottom? If the thing that matches is a bottom, then I think that means that I have done a rotation clockwise. And if I've done a rotation clockwise, that means that top is the opposing one. Okay. Oh, so much fun. All right. What if I see right matching? I should never see right matching unless it has been flipped. So in that case, but that what? Okay, now I'm thoroughly confusing myself. Is it possible for us to see top? No, because again, top would need to be flipped. Okay, actually, yeah, I believe that. Ooh, so confused here. Yeah, I guess I don't understand how this could happen. So right goes to left, right goes to bottom, rotated 90 degrees. If we see a match on... Okay, yeah, I think I understand this now. Yeah, I can find the matching edge. I'm just trying to figure out how I'm supposed to rotate to adjust it. All right, let's actually just look at this graphical example again, just to make sure that I have the understanding correct. How? Yeah, I sympathize, John. 1 a.m. is really hard. So, let's think about this again. Okay. So I find some edge that match. Oh, okay. Now I understand the logic here. So the logic here is I look to see how it originally matched. and then I have to flip it around accordingly. Yeah, so each piece has 8 ways that it might potentially match the pattern. Because it can go this way, this way, this way, this way. Okay, I understand this now. So it kind of almost doesn't matter to a degree. Okay, so if it matches this way, then I use the original rotation and the original flip. If it matches this way, then I use the original rotation, but I rotate right. Okay. If it matches on right, yeah. If its right edge matches, that means that I need to... Oh, okay. I understand how to think better about this. Let's just think about it this way. Okay, this causes this to make my head hurt less. So now I can think about, did I have to flip this around in order to make the original piece, in order to make the next piece match? And then I think about how to, okay, now I understand. Yeah, I thought about storing it in a clockwise or counterclockwise format. But the problem with that was that then it makes the left to right case, right? Like if it's stored clockwise or counterclockwise, then the straightforward case of they lining up doesn't work anymore. Okay, so let's draw the. This is reminding me a lot of the gesture of... This is reminding me a lot of making gestures, or of like right-hand rule, left-hand rule gestures, which is hilarious. All right, so I'm trying to evaluate this edge here. So if I find a left, then I know I'm good. Find a bottom, then I know I rotated. If I find a right and I had to flip myself, then I know that I've got an opposed top. Okay, yeah, that makes sense. So we'll... Okay, and top. Okay. Let's have a look at this here. Okay. So I see a right, and I had to flip myself. And that means that this piece was rotated by 180 degrees and was not flipped. And therefore, that I need a left flipped. As my next. As my next. Right. Okay. All right. Let's think about this once more. If I had to flip my right to make it match, I saw a right. What if I saw a top? Okay, I'm understanding now why Ariel. I'm understanding now why Ariel wanted me to do this the other way. Okay. I understand. So I think the way that simplifies it is you know what? This is fine. I'll get a new piece of paper, and then we'll do it with a slightly different coordinate system. Okay, let's do it with the clockwise. Okay. So now, just going to quietly reverse these. So now, ooh, there's a bug here. Oh, no, that actually was correct to begin with. Okay. This one is now bad. You know what? Yeah, new pieces of paper. New pieces of paper. We're doing it. I'm having fun, but I'm suspecting this stream might go multiple hours. So I'm going to now remind you that these videos are captioned after they go up, but it does cost me money to ensure that they are captioned, and the price is commensurate to the length of the stream. So every hour that I stream costs me about $40. Just so you know, if you feel like chipping in some bits or throwing me a subscription, I would appreciate it, so I can continue to offer accessibility with this. Okay. Top, right, bottom, left. Top, right, bottom, left. Positive side. Okay. Negative side here. We've got top prime. We've got right prime. Okay, now I'm understanding why Ariel wanted me to do this. This is a little bit easier. This is now bottom prime, and this is left prime. Top prime, left prime, bottom prime, right prime. Okay. Wonderful. Thank you, Ariel, for the subscription. Thank you, Eric, for the cheer. Awesome. Cool. All right. So now, if I have a loose edge of some kind, in order to match it, the next piece, if it matches straight up, is always going to be a flip of the last kind that we saw. Okay. Is that correct? So if it matches what I saw straight up, then I need to flip it. Yeah. Okay. All right. Okay. I understand now why Ariel thinks that that's why that's better. Okay. And now also, coincidentally, if I saw a left, then the next one will be a right, and so on and so forth. Yep. So what does that say about what my next loose edge is going to be? Pace right, then left. Okay, so loose edge will be okay. Is that true though? So if I saw a bottom that matched, then the next one has got to be a top. Yep, okay, I can believe that. Okay. Now, I'm a snap. Yes, it's true. See? Tiny snow leopard. Tiny snow leopard Liz. Okay. And then that means that my rotation I did a flip, then the rotation will be, if right matches, it was not rotated. Bottom matches, okay, now I understand this. This feels better. dir plus 2% 4. Is that also correct? Does that work out correctly? So if I get a right is direction number 1. Oh, I see. So what this secretly is left. I expect it to be left. So if it is left, then I subtract left and get 0, and this is not rotated. If I get top instead, then it means that I had to rotate 1, 2, 3 times in order to get that rotation. Yeah, is that correct? God, my head hurts. My head hurts a lot. Eric, why do you do this to us? Hey, Viwu, I am tangled up in knots on physical manipulation. It turns out that my inability to understand the way that physical objects interact also apparently applies to this puzzle. Let me show you this, for instance. My arm is covered in a bruise right now because I failed to understand that, there was an object over there the other day and I bumped into it. So, yeah. Okay. Let me just check this. So if I did have to flip this, then I did have to flip the previous thing to make it match. Then it means that, yep. Okay. Yeah, Ariel, you're 100% right. Thank you for the hint here. All right. What does this say about rotation? And what does this say about direction? Okay. So if I had this, I had to flip the right edge to make it match. So left here, oh, but that's always going to go to right, so that's fine. No matter what, it's just, okay, so that's always going to be the same. Oh, but with the caveat that what happened if it matches then do I potentially need to flip the loose edge? I think I do. This is pretty terrible. I do not like this one bit, Sam I am. Let's just see whether this even compiles. Okay. Don't care about this. Okay, right now it's not matching anything. Wonderful. this should at least match one thing, you'd think. Did this at least not break? This is indeed that number. Okay, so I didn't break that. All right, let's add some debug output here. Oh, wait, is this code actually executing? Oh, I need to run it with... Okay, so now we start with a given edge, the given corner. Where is 66? So we're starting with the tile ID 3079. Oh, yep, there's the edge 66 there. Okay. So we need to find the flip of 66 to make it match up, I think. So why is the flip of 66 not matching anything? Just have a look here. Yes, there's no 66, so the complement of 66 is what we're looking for. Oh, I'm not actually saved. Yeah, okay, I did need... Oh. Wait, but this should work, should it not? Just try something. Oh, I need that. There we go. Okay, now that works. Kind of. Yep, so I do find 1951. I do find 2311. This should not get repeated another time, though. Okay, so now we're making some progress. Huh. Now I'm pretty sure this is correct. So for my 3x3, I want to iterate twice. Oh, it's interesting. This is now being very non-deterministic. All right, so we need to make sure that we don't reuse pieces. Let's at least deal with this. All right, so now that is actually generating a proper sequence, which is good. I'm a little bit alarmed that this is not necessarily doing the rotations correctly, but so why is it sometimes failing to match? Because sometimes it is actually able to find a full side, but sometimes it's not, and that's very disturbing. Okay. Let's run it on the simple input. 2791. Okay, and then it finds that 1489 matches. Okay, that's fine. It doesn't. It's kind of arbitrary which side you start with. That's fine. And then we then need to go and look for a corner that matches after that. All right. Now I need to extract this out into a function. So let's figure out how we do this. I guess the way to do it is I'm going to do it this way. Okay. Function. We need candidates. All right, something like that should do the trick. All right. Oh, and I also need the tiles. That is one long function signature. Edges and sides. Oh, right. Where is sides used? Oh. Okay, that looks good. Okay. All right. Yep, that's correct. Okay. I equals all right. All right, if we're doing bottom, R anchor is 1. If we're doing left, C anchor is -1. If we're doing top, then R anchor is -1. Okay. All right. So start from a given place. Always start here. This is going to be an annoying if statement. I don't like this, but I'm doing it anyways. All right. I hate this. I hate this a lot. Okay, there's a better way to express this. We're going to do it this way. All right, let's get my De Morgans right. We're going to get my De Morgans right. See, look who just aced her De Morgans after screwing it up the last time. Okay. All right, now that should work. Oh, okay. Think this might work? Let's try it. Line 173 is off. All right. Where's start used? Start is not used at all. All right. Oh, there you go. Okay, that is looking less promising. So what did I do wrong here? You know what? What if I just fed it everything, assuming that Erica's not being evil? Let's just try that. Just going to try everything and see what happens. Okay. Line 167. Oh, yeah, that doesn't need to be there anymore. Okay. That should definitely not be happening. Oh, I see the problem. So I need to specify what is used already. Right. So now start at position 0, 0. We're traveling right. Hello, Sympathy. I'm glad that you're going to try Advent of Code. It's super fun and exciting. It's just also kicking my butt a little bit today. R times C, anchor times I. What's happening here? So 1471, 1489, starting 1. Wait, that's not right. Should be starting... Okay. Should be incrementing column. Oh, whoops, that's over here. My bad. There we go. I knew there was some bad copy-paste in there. All right, now that's filled in correctly. So 1951, 2311, 3079. Does this work on my actual input too? Yes. No, it doesn't. So it's failing to find one thing. Who's it failing to find? Okay, so there's obviously some bug here. Oh, whoops, that's the problem. That's off. Okay, so now I actually found a working set of these, which is super exciting. But sometimes it's still utterly failing to find a path around, which shouldn't be possible. Oh, because I don't know which corner is which. So there has to be the so if I couldn't find a way to traverse starting from that corner, that means that I picked the wrong. That means that is not the right hand corner. Okay, I understand now. Okay, we got this. We got this. And then let's just quickly fill this in once we have it. All right, so if we are unable to traverse, all right. Okay. Okay. Just to make sure I don't infinite loop my CPU here. Okay. So now we should be at 0. Okay. We should be at 0, count. And now we go down. Oh, and I need to know what the loose edge is, but I guess I can... Okay. This one isn't right. This needs to be... Okay. This can actually just be this. So that was actually fine. Arg. Okay. Okay. Hopefully this works. Think that'll do. Line 233 is wrong. Why is that wrong? Unexpected comma. Okay. And outer is now no longer a valid. Sure, outer is a valid. Oh, oops. There. Assignment to entry in nil map. Okay. Let's see, what have we here? Oh, like that. Should not be happening. So what did we do wrong here? Oh, I see the problem. There. That. Okay. So now this should, in theory, always find the correct direction to go. Oh, in fact, I don't need to guess. I think the reason I don't need to guess is, okay, I don't actually need to guess this way because I will know which corner I need to use. The way that I know which corner I need to use is the singleton tiles. I'm going to change this. Okay. All right. So if all edges matching right and matching down. Not the top left corner. Okay. Okay. Did I get that right? All right, let's reset this and try again. Oh, this should be bottom. Okay. Failed to traverse starting from... Where did we get this wrong? Oh, I think I see. Nope, that's not right either. So how did I determine something was a corner? If it had... Ah, okay, I just have a polarity reversal. I think that's correct now. What is all edges? So there need to be at least 2 tiles sharing that edge. If there are fewer than 2 tiles sharing that edge, then we know it's bad. What are we doing in here? Oh. Duh! I got that. I got that reversed. Yep, okay. All right. So now that reliably finds the top left corner. Good. Okay. Now that feels much better. Failed to traverse down from top right. Okay. And now we do the same thing again, starting from count, left. So let's make sure that that works. Okay, that worked smoothly. Now, finally, in fact, why don't we do it this way instead? I think once I have the first stripe of the row, then I can just go down column by column by column. All right. Okay, I am feeling closer to the solution now. I was super worried earlier, but I think I have it. Okay, let's do this way for simplicity. All right. So this should still work. All right, now I think that reads a little bit better. All right, so now all right, let's just make sure that this still works. Okay, we've got a slight bug here, that's fine. Oh. There. That's correct now. All right, I trust this now. Just make sure that this works. So 2971, 1489, 1171. Okay, that I think works. I just have a slightly inverted diagram, but that's fine. What does 2971 look like? Yeah, okay, so he flipped it already. Yep, so, yep, that is correct. So if I start with the n-modified 2971, that is the top left. Okay, that's good. Okay. Yay, getting there. Okay. We got this. We got this. think I'll finish before midnight. Pretty confident I'll finish before midnight. Okay. So now, from row 0, column C, in fact, I don't need to specify what the loose edge is. I should be able to infer it based off of the rotation. Okay, so we'll deal with that in a second. Okay. So let's see how we deal with this. If I'm not actually reading the Twitch chat right now, I'm sorry, y'all. I'm focusing too hard on this. Okay. All right. So let's figure out how we derive this. A given rotated piece should be able to get edged. We need to know where it's coming from, which is a all right, so we call tiles our tile ID, and then we call T edges. But now we have the interesting conundrum of, now we have to go back to the pieces of paper. And that's even supposing that my pieces of paper are correct, which I don't know. So if I'm interested in knowing, I need to know what the rotation and whether or not it's flipped is. Okay. So normally I get returned them in the order top, right, bottom, left. So I'm asked for the, okay. If it's flipped, I'm asked for the top or the bottom, I return the top or bottom flipped. If it's flipped and rotated, the right and left have swapped and are flipped. Okay. So we swap right and left if needed. And then after that, does it matter whether I flip left and right first and then I rotate? Yeah. I think something like this should do the trick. Let's see. So if it's not flipped, and I'm asked for the top of a thing that has been rotated once clockwise, then I want to wind up at left. Which, okay. It's rotated twice. Okay, so that's not quite correct. I think I need to do that. Okay, let's see if my understanding is correct now. So I'm asked for the for the left side of a piece that has not been rotated or flipped. I should get the side is going to be left, plus 4, which doesn't do anything, minus rotation, which is 0. Okay. So if I've rotated once, then I ask for the left-hand side, then side is still left. Rotation is now 1. Side plus 3, which then flips it back 1. Yep, that's correct. Okay, I believe that. Okay, what if it's flipped? So if it's flipped and I ask for the left-hand side, I should get the left-hand side that flipping needs to happen after we've evaluated the rotation. Okay. think I need this. I do not love this. Okay, I hope I wrote this correctly, because otherwise I'm about to be in a lot of trouble. Okay, let's hope that I got this correct. Yeah, I also failed out of organic chem, where is X, so this should not be a surprise. These skills are very, very challenging for me. This is part 2. I've already finished part 1. Get edge in direction dir. Oh, and it needs the tile list as well. Okay. Use declared but not used. Yep, that's fine. I don't need that anymore. Okay. So that works. And I was able to successfully iterate all the way down. So let's see what this looks like, because I'm really curious now. I don't like how I have a bunch of empties. There should be no empties here. Let's run it on the simple. Okay, so I successfully got the top row, successfully went down the first column, but for some reason I failed to actually go down the second column. Why is that? That's correct there. Oh, I see the problem. if I didn't match any pieces, we know we have a serious problem here. So I need to, at the end of this loop here, say, hey, okay. Yep, so now it says correctly failed to traverse down column 1. All right, so my suspicion now is that I am finding the incorrect I'm recording the incorrect rotation, or my math to determine what the leading edge is wrong. So let's check this. How do I do this? You know what? I'm going to write the more fun code that I need to eventually get to, and we'll come back to do this because I am getting a little frustrated with this, and when you get frustrated with something, there's always another part of the problem to work on. Okay. So for the mosaic, pixel add chord RC int. Okay, so yep. So the mosaic row is going to be.
Is there going to be a point at which I can do the dishes or no?
Just go ahead and do the dishes, because yeah, I am going to be working on this for a while.
Yeah,
that makes sense. All right. So the mosaic row is going to be. R divided by 8. Take call, it's going to be C divided by 8. So now we need to look for M index RC T crop C% 8. I think that should do it. All right. So now we need to sweep the entire thing from each starting point, looking to see whether the pattern matches. So is the sea monster required to... Oh, the sea monster could potentially have noise. Only the hashes need to match. Okay, great. So, going to define here the sea monster lookup function. Okay, monster top left chord, tiles, map, int, C. Okay. So I know this is inefficient, but hopefully it doesn't run too many times. What does Ariel say? Yeah, there are simplifying assumptions for part one that do work out, and that's in fact what I did. Okay. So sea monster. All right. All right, that should work. Where is this? Okay. Sea monster for okay. If car is not equal to hash, then continue, and then if pixel at chord tiles r plus r offset c plus c offset not pixel at chord, and we're expecting that, then turn false. Okay. So once I have this arranged, then we need to iterate over the entire image. Sea monster at loc. All right. Is less than 10, 100, wait, yeah, 100 times tiles. All right. Let's just make sure that I'm finding all of the monsters. I think the one thing that is frustrating to me, Mech Power, is like this rotation stuff is really irritating me because it's not a thing I'm very good at. But, you know, if it's something that you're not good at, practice, right? Okay. All right. If okay. Okay, I'm going to need a chord class as well. Good night, Ellie. Okay, so we're making a list of monsters that we find. Chord RC. And if we don't find any sea monsters, then we know that we need to, then we know we need to rotate or flip the entire thing. Okay. So let's debug this really quick. So what is my bug here? 29. Oh, struct. That's fine. And 47. What? Oh, RC int. Oh. It's not a... Golang does not have static blocks, which is super, super annoying. Just do this instead, it's fine. Oh, it's called crop. Not. Oh. There we go. All right. All right, so that code compiles at least. Just define a function here really quick. I know I'm going to want that as well. So now from int to tile. This can just be Oh, Ariel has a point that, yeah, you could just artificially create the every single flipped rotation. and then you could just use those literally, and then not have to bother with any of the rest of this. That is 100% true. But unfortunately, I did not do that, so. Monsters. All right, let's see whether that works. Oh, that's missing a return. Getting there. Okay, let's check this in for a second. And push this up to GitHub. Okay. So let's really quickly verify that all of this stuff is working correctly. Okay, so I did find, indeed, 2971, 1489, 1171. So, in theory, we should be able to... 2971 was not flipped. Square arrangement that causes all of these to line up. Yeah, that's correct. 2971 not flipped looks like this. And 1489, it says that it should be false, comma 2. Not flipped, rotated twice. Okay. Let's check that theory. So 1489. The way that I have it, (1489) has this line in it. Let's just check this real fast. Wait, sorry, 2971. Is that row? So it's been flipped and rotated twice in their example. It's a little annoying. Is that correct? Think about it. So yeah, because I think I'm going to literally draw the pattern of it on this piece of paper. I freaking swear. So one, two, three, four, five, six, seven, eight, nine. I need one more. switch on here. Okay, so right, so in order for this here to wind up on the bottom, it needs to be, yeah, rotated twice and flipped. Yeah, I think that's correct. I can see through the paper here. You can't see it, but I can see through that. So I believe that in their version, in my version is flipped twice and rotated relative to Eric's solution. Yeah. Sorry. Here you go. So top facing, in order to flip it to look like this, it has to be rotated and flipped in order to appear correctly. All right. Nathaniel, I'm not sure I understand what you mean by I'm not sure what you mean by only two of them were not flipped. So okay, 1489 then. 1489 also has the same, should have the same rotation applied to it. No, that's not correct. 1489 has, yeah, it's had the same rotation applied. Has it been rotated at all then? If it also was flipped twice and rotated in Eric's example, in my example, it should be completely unmodified. So I should be able to take 1489. In fact, let's just do this in a text editor. That'll be easier. Okay. So I've got 2971, which is completely unmodified. So I've got this. And then have to get 1489. Which I believe winds up looking like this. Should wind up looking like this in order to make the puzzle pieces line up correctly. I wish it were easier to copy out of this, but that's fine. Okay, now I think I understand where my problem is. So I falsely report this as rotated when it was not in fact rotated. And then down here will be 2729, 1427, 2473. And then down here will be 1951, 2311, and 3079. I think that's the difference between what I derived and what Eric's example shows. Okay. So if that's correct, let me just check that. So 2729, this tile here in Eric's example yeah. $29.71, 27.29. Yep. Yeah. So Eric's example is just visually flipped from mine. Okay. Excellent. I think I understand this. Yep. So this one should be verbatim here. Yep, that's correct. Okay. So now that I understand that, so why is that showing as rotated 2? That's showing... Is this just wrong? Let's try running that. No. This one wrong. Ah. Okay, yep, I just had an off by 2 error. That was it. All right. That was literally it? Okay. Zero, 1, 2, 3. Okay. All right. All right. Almost there, almost there, almost there. All right, I will wind up rotating this. I'm just making sure. No! Okay, so it successfully traverses on the on Eric's example now, but now I have some other bug. Okay, I bet there's something wrong with my flipping code. There's probably something wrong in here. Going to have to print out these binary values. Okay, well, let's make sure that my example runs on the simple input, because I can at least get that working end to end. set this to rotation plus plus. Oh no, oh no, oh no. But if I rotate the entire thing... Wait a second. I can avoid having to rotate the whole thing by just looking for the sea monster in flipped orientation. Yeah, I am starting to lose my concentration, but that's okay. Yeah, because we might have to... Okay. Okay, let's do it this way, because I think... Yeah. If I rotate and flip the monster, then I don't need to do anything else to the matrix, and it doesn't really matter what the actual rotation is because I just need the count of total number of tiles, and then everything that's not. Yeah, there are 2 sea monsters that are marked with O's. That's one. That's the other. Does it say that the monsters could overlap? Pretty sure that the sea monsters do not overlap. Let's assume that. So okay. So in that case, I don't even need to know where the monsters are. I just need to know the monster count. Monster count is not equal 0, then break outer. All right. So now, I happen to know that a monster pattern contains, let's count this by hand, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Monster count times 15, and now I just need to know how many are in the mosaic. All right. Cropped. Okay. Yeah, I did the same thing that Tess did for part 1. which is just look for things that don't have edges. So I think this should deliver my final answer. I just need to make sure that I get all the rest of this correct. All right, find monsters. Rot. Okay. All right, and I don't need the chord class either. Oh. Rot, rot, rot. Yeah, this is definitely a problem that is taking me a lot of time. Okay. I have another bug here. Oh. There we go. All right, so the answer is not 303. And the reason is that I do wind up finding 2 sea monsters. Wait a second. This feels trivially guessable, Eric. Like, Eric, I'm pretty sure that I could guess that there are 5 monsters in my image and just count the pixels in the image. Eric, would it be bad of me to do that? So I'm pretty sure that even if I were rate limited to guessing every 5 minutes, I'm pretty sure that I would eventually be able to get it. Especially if Eric tells us whether the number is too high or too low, it would be pretty easy to bisect. Yes, I know it would be end sporting, but like, I want to table flip because like. There is going to be some number of monsters, and I know that I can take the total number and just subtract out. Yeah. Oh, this feels bad, man. Like I'm a little bit annoyed that it took me this long to realize that was a potential solution. Okay. On the other hand, I did see people literally, throw things into Wolfram Alpha the other day. So, like, there are varieties of not sporting, I will say. Okay. So we should be able to find 1171 was flipped, it claims. Let's check 1171 to see whether I believe that. Let's make sure that that this is correct to begin with. So 1171 is this tile. So yeah, if I flip it, then I would have to rotate it twice as well, I think. See. No, if I flip it, I think it does the correct thing. So why does it think it was also rotated? That seems implausible. So this tile, we think, just check this. So if I performed a flip, where are my pieces of paper? Okay. So if I have if I have something like this, oops, there we go. Top left, right, except for it's mirrored for you. Sorry. So if I have this, and I flip it, then I also then would need to this tile here also needs, then after it is flipped, no, it's just a straight, is it just a straight rotate by 2? Yeah, I don't think this is flipped. I think this is just rotated by 2. So if that's the case, wait. Oh, then my fetch function is bad. Yeah, okay, that's right. This fetch function is bad. Does not take rotation into account. Arg. I knew that there was going to be a problem here. Wait, Ariel, I'm not sure I understand what you mean by flipping reverses all the edges. Like, flipping does reverse the numerical quantity of all the edges, but it does not... It preserves, depending on which direction you flip, it preserves which one is top and which one is bottom. Okay, well, I'm going to go back over here and work on this for now. Okay, I know that I'm going to need to do something here. And I know I also have a... How do I get pixel at coordinate? So if it's flipped, so the rotation has the potential to change where I start reading from, which corner I start reading from, and what direction I go. And the flipping also has the potential to transform a flip reverses all the directions, does it not? Yeah, it does. Okay. All right. Right. No fancy math tricks here. How many people have finished today, by the way? I'm really curious. Less than 1,000 still. Yeah, that figures. Okay. It's not rotated. No, but it's not true. If it is flipped, the R and C if it's flipped, then I switch which row and column I'm reading from. Something like that needs to happen. It's rotated and if it's rotated after being flipped, though, what happens then? Then normally would read bottom to top, but I still read bottom to top. Is that right? Spatial reasoning is hard. Okay. You know what? I'm just going to number these freaking things. So this is 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, dot, dot, dot. 1, 0, 2, 0, 3, 0, 1, 1, 2, 1, 3, 1. What is that? That's 1, 2, 1, 3, 1, 4, 2, 2, 2, 3, 2, 4, 3, 2, 3, 3, 3, 4. Like this. Okay. All right. So if I rotate, a straightforward thing to do is to the column and the row swap. So and the column starts from the highest the row starts, sorry, yeah, if I'm asked to read from a given row, the row becomes the column and is the same. The column becomes 8 minus row. No, I'm forgetting which one converts to which coordinate system. Okay. So in order to read from 0, 0, if I'm asked to read from 0, 0 on a piece that has been rotated, I need to actually read from row 8 minus it's going to be 8 minus C%8 because, yep, that's correct. So if I'm asked to read from the 8th position, I'm going to want to read from the 0th row. Yep. And the columns, if I'm rotated once clockwise, if I'm asked to read from row 3, then it's actually just going to be column 3. Okay. Spatial reasoning. It's my Achilles heel. Okay. For flipped all the way upside down, then we just reverse. We start from the top left, and for asked for a row and column, that makes sense. Okay. Now finally, pretty sure this is just the opposite permutation. Is that going to be the case? Let's see. So I have rotated 3 times to 3, asked to read from the 0th row, 0th column. Then in fact, that translates into the zeroth row and the 8th column. Yep, that's correct. Okay, if I'm asked to read from the first row, 2nd column, then that becomes reading from the first row, 2nd column. And I need to translate that into reading from the 2nd row and 8th column. 2nd row, yep, and 8th column because I haven't changed which row. Yep, okay. So now let's deal with the flipping. I do want to kind of apply the guesser, but I also don't want to cheat myself of this, you know. So 0, 0. 0, 1, 0, 2, 0, 3, 1, 0, 2, 0, 3, 0, 1, 1, 2, 1, 3, 1, 1, 2, 3, 2, 2, 3, 2, 3, 3, 2, 3. Okay, so this is now my flipped. So, okay. If it is flipped, but not rotated, then my x-coordinate, then my row is always flipped. If I also applied a rotation after, I think I understand where I've gone wrong. So my flip logic is only flipping this direction, but if I rotate and flip, I'm not sure that I'm accounting for that correctly. All right. So let's see this. So my input has 144, so that's 12. It's 12 by 12. It's 12 by 12, and each thing is 8. 1 second. Let me just take a wild ass guess here. So it's 12 by 12 by 8 by 8. So there are 216 pixels. The sea monster image is about 3 by what? Three by 20. Okay, so the sea monster image is 3 by 20. So if we assume that that the sea monsters are somewhat sparse, there are going to be at most 153 sea monsters in the entire thing if they were literally packed wall to wall. So I'm going to guess that I have 30 sea monsters. So if I have 30 sea monsters, let's just do this real fast. Just going to run this real fast. Where is sum used? I hope sum is not used somewhere. Oh, that's fine. That's fine. So there are 2130 set pixels. So 2130 minus, how many did I say? There are 16. 15. I'm going to guess 1680. What? Okay, that was bullshit. That was complete bullshit. Did you see that? Eric, did you... A9, did you see that? Okay. I'm going to solve this properly tomorrow, but seeing as it is midnight 30 and I have solved the puzzle technically, I'm going to wrap up the stream here and do this during daylight hours. So have a good night, y'all. And yeah, I guessed that on the first try, and now we can see the sea monster, which is hilarious. Okay, see you all tomorrow. We'll solve this correctly tomorrow. Have a good night. Let me raid someone else. Someone have a suggestion on who to raid? Is anyone even still going from our community? I'm sorry, this is just too funny. Okay, let's raid Irene's. Have a good night, folks. And if you're watching us on YouTube, please like and subscribe. And I'll see you for tomorrow's episode.